Hello people, I'm Bharat Acharya. Welcome to my video. Today's video I'm going to teach you programming of 8086. This is my first video on 8086 programming. I'm going to make many more. I'm going to tackle big programs. We're starting with a small one. The idea is to get you comfortable with this language. There are so many people who get scared of programs. I don't want you to be that. Once you understand one program thoroughly, every line of it properly, you're going to start enjoying programs. It's a skill. It takes time to acquire. Once you master it, then it becomes an art. And then after a point in time, you're going to love programming. But that's where I want to take you. Let's start. Let's start with the first simple program. So here's your question. Write a program to add two 16-bit numbers. Simple. Program to add two 16-bit numbers. Okay? Let's start. Now, the program that we write is in assembly language. If you're familiar with C, C++, Java, etc., they are higher level languages. Higher level languages are compiled and converted into binary language by a compiler, in Java by the JVM. In assembly language, in the language that we're going to write, we will give a program to a software called as an assembler. There are various assemblers in the market, TASM, MASM, XASM, that's called cross assembler, etc. There's so many. They're free downloads from the internet. You can just get one and practice programs at home, which I'm sure you would do after you know these programs. Now anyways, so you write your program in assembly language. Listen carefully. You give this program to the assembler. Assembler converts it into machine language, stores it in the memory, gives the program to the processor, and the processor executes it. Okay, so there are three parties involved in a program. You, the programmer, the assembler, and the processor. Okay, you write the program, assembler converts it, and processor executes it. So, you are writing your program for the assembler. Get this clear. You're not writing it for the processor. You're writing for the assembler. If you satisfy the assembler, assembler will satisfy the processor. So, you have to follow all the syntax rules which are laid down by the assembler. So it's a new language, you're starting with it, understand the rules. The first program is super important. I'm going to make videos of many more programs. I will not teach these basics in those programs. Okay, so pay attention and understand every word that I'm talking. Now, just like a C program, if I tell you, I hope you're familiar with C. If I tell you write a C program to display hello world, honestly, it's a one-line program. Printf, bracket, quotation, hello world, semicolon. Am I right or not? Or C out, whichever syntax you're familiar with. But that line alone cannot execute. For that line to execute, you have to do hash include, void main void, open close bracket, curly brackets, and then write a program, write get ch with a bracket and quotation mark, then it executes, and then you get to see the message. So similarly, our program to add two numbers is this small. This is what it's going to be, okay? But for this program to execute, you have to write so much. There are a lot of formalities which have to be written, otherwise your program will not work. Now, people who are not interested in this subject, think of them as boring formalities. People who want to learn this subject, they understand each line and they enjoy the gist of it. There's so much knowledge in it. And I'll tell you one thing very clearly, okay? The more you understand this, the easier you'll find C and Java to understand. All languages have the same principles. The syntax changes, but the principle of programming is the same in all the languages. Once a programmer, always a programmer. You get good in one language, you'll be good in all the languages. Okay, now let's start. So as I said, you're going to write blocks. So this is how programs go in assembly language. Data, segment, data, ends, code, segment, code, ends, and then finally end start. Everything over here has a serious meaning, okay? Pay attention. As I said, this program is an assembly language. When you give this to the assembler will convert this into machine language and give it to the processor. Assembler does this in passes. What is a pass? A scan of the program from top to bottom is called as a pass. Now, when the assembler scans this program, it looks for some keywords, also called as assembler directives. Hear this carefully, assembler directives. In Bombay University, it's a 10-mark question that keeps coming all the time. In the last 10 papers, it's come 3 times. So it's very popular. I'm sure whichever university you would be from, this is an important question to understand. I'll be putting a separate video for that later on. Anyways, so these are called assembler directives. Whichever ones are required for programming, those I'm teaching you right now itself. Don't worry. So the assembler sees this much. It understands a few things. First, there is a keyword by the name end. Obviously, what does it mean? End of the program. Anything written below end will not be seen by the assembler. So what do you write below end? The name of the author, the name of the organization when you write professional code, the logic of the program, further improvements for the program, any errors that are predictable in the program, blah blah blah, theory about the program. So there is no syntax for anything written below end. It is just your language. You can write what you want. The word start has a very deep meaning, but not now, too early. Probably 10-15 minutes from now you'll understand. Now look at it. There is something called as segment, not data, segment. And there is something called as ends. Segment and ends. Ends means end of segment. End of segment. So segment and ends are the boundaries of a segment. A segment begins with the word segment and ends with the word ends. Did you understand? It's like in C programming, a function begins with an opening bracket and ends with a closing bracket, those curly brackets. Similarly over here. Now, whatever you write next to the word segment becomes the name of a segment. Tell me, in C programming, when you declare a function, do you give it a name? Obviously. Can that be any name you want? Yes. As long as you follow the rules of nomenclature, it can be any name you want. But you give functions sensible names. Suppose you want to make a function to find factorial. You'll call it fact or facto or something of that sort. You won't call it square root. But can you call it square root? Yes, it's a name. By calling it square root, it won't calculate square root. By calling it factorial, it won't calculate factorial. You have to write code for that. It's just a name that you have given. Similarly, data and code are the names of these segments. Get this clear. They are just the names of these segments. That doesn't mean this is the data segment and the code segment. I'm sure you know there's something called as data segment and code segment. I'm sure you know that. If you reached here, I'm sure you've done the earlier part. There is a video for that. Please check it out. In case you don't know. Okay? I'm sure you know. So, later on, I am going to make this the actual data segment and the actual code segment. That's why I have given them names data and code. But get this clear. By calling it data and code, they don't become data segment and code segment. They are just names. You could have given your first name and your last name, it still works. You can call a function your name. It will still do what code it is supposed to do, whatever code is written inside. Okay. So, the moment assembler sees this much, assembler goes to the memory and creates 2 segments. Names them data and code. Whatever you write inside data will be stored here. Whatever you write inside code will be stored here. Please tell me, did you understand this? Now pay attention to the words I said. What did I say? Who is making the segments in the memory? We or assembler? Yes, the assembler. That means where they are stored in the memory will never be known to us. We don't know the address. We don't care about it. We will access segments by their names. Their addresses is the job of the assembler. Just like in a C program, every function you have written in your life would be stored somewhere in the memory. Do you know its address? No. Do you even want to know its address? Who cares? As long as you have given it a name, you will access the function by the name. The compiler substitutes the address. Similarly over here, the assembler knows the address. You will never know the address of these segments. Please tell me, did you understand this much? Let's go ahead. So, as I said, what we write inside code will be stored here. What we write inside data will be stored here. Now, what do we write inside code? Inside code, we will write the actual program to add 2 numbers. That will happen inside code segment. What do we write inside data? We are going to create variables. Exactly. Like in C programming, you create variables. Now I'm going to teach you how to create variables in assembly programming. Tell me, are variables required? Of course, you can't do serious programs without using variables. Now, look here. How do you create a variable in a C program? You write something like int a is equal to 25. I'm sure everybody is familiar with this syntax. I've created a variable by the name a of the type integer of the value 25. So what are the 3 things that you have given? The name, the type, the value. Say it again. name, type, value. No matter which language you are learning, 𝗕𝗔++, Java, VB, Oracle, etc., etc. If you want to make a variable, these are the three things that you give. The syntax will change, but the concept is the same. So, similarly, when you're making a variable in assembly language, this is how you make a variable. You write A, DB, 25H. Now try to decode them, what they are. A is the name of the variable, 25 is the value of the variable, and DB stands for define byte. Say it again, define a byte. So that's the data type. There are 5 data types supported by assembly language. Look here, they are DB, DW, DD, DQ, DT. DB stands for define byte. DW is define word, define double word, define quad word. Quad word means quadratic word. Quadratic word means 4 words. And define 10 bytes. You can say 10 byte, you can say terabyte, you can say tetrabyte, whatever, it means the same, 10 bytes. Now, what are their sizes? Look here. Byte is 8 bits, word is 16, double word 32, quad word 64, 10 bytes. 10 bytes is 80 bits. You understand, right? Obviously, 1 byte is 8 bits, 10 bytes will be 80 bits. Come on. Now, our processor, 8086, is a 16-bit processor. That means it does 8-bit and 16-bit operations. So, the most commonly used variables will be byte and word. Define byte and define word because they are 8-bit and 16-bit. Okay. Now, you would be wondering, why have they created such big variables? That is because this language is not only for 8086. Many universities in their syllabus for 8086 also have an introduction to 8087, the math coprocessor. When you learn 8087, you know it works on floating point numbers. Now, floating point numbers are of large sizes. They have 3 formats: short real, long real, temp real. Short real is 32 bits, long real is 64 bits, and temp real is 80 bits. So it's not a coincidence that the sizes are the same. These formats, these sizes are created for those formats of 8087. Is that clear? When you're working with 8086, you'll be mainly working with byte and word, and sometimes with double word when you do multiplication. Multiplication of 16-bit numbers gives you 32-bit result. Now, come back over here. Very interesting. Pay attention. This will open your mind here. Look here. When I write A, DB, 25, I've created a variable by the name A, defined as a byte with the value 25. Now, when I say a variable is created, what does that mean? It means space is reserved in the memory. In which segment? Code segment or data segment? Since I made it in data segment, it will come over here. How much space is reserved? I have defined a byte. Byte is 8 bits. You know your basics. One memory location carries 1 byte. So if you want to store 8 bits, you need 1 memory location. So one location will be reserved. It will be called A, and its value will be 25. Tell me, did you understand this? Now that I have declared this variable, I can now use it. Without declaring a variable, you cannot use it. If you try to use it, you get the error undefined variable. Now since you have defined the variable, you can use it. So let's use it. Suppose I write move CL, A. Tell me, who gets what? Who gets what? CL gets the value of A. A is how much? 25. So CL will get the value 25. Tell me, did you understand this much? Now I have a question. Listen very carefully. This point will make you understand variables for life. Look here. When you write move CL, A, this is assembly language. You know you're writing a program in assembly language. The assembler converts this into machine language. Machine language means every instruction has an opcode. Okay, I've covered all of this in the initial lectures. Please check out those lectures if you don't know what I'm talking. Okay, so every instruction has an opcode, the binary equivalent of the instruction. Now look here. Will there be an opcode for move CL, A? No ways. There is an opcode for move CL. A is our variable. Okay, so when the assembler converts this, it will substitute the opcode. For move CL, it will substitute the opcode. For A, what will the assembler substitute? Yeah, tell me, what will the assembler substitute? 25. That's what you think. No. Get this clear. Any variable, whether it's C, Java, VB, any language in the world, whenever you write a variable, the assembler or the compiler will never substitute its value. It will substitute its address. Why? Because A is a variable. On declaration, A was 25. What do you mean by the word variable? Variable means something that can change. On declaration, it was 25. That doesn't mean it will be 25 all throughout the program. Do you understand what I'm saying? This is the whole difference between a variable and a constant. A constant remains constant. A variable can change. So, before this flag, if I write increment A should become 26. So when I write move CL, CL should not get 25, CL should get 26. Now, when will A get incremented? When I write this, when this is assembled, or when this is executed. Remember what I tell you in the starting of the lecture. There are three stages to the program: the writing stage, the assembly stage, the execution stage. When this will be executed, A will become 26. But while it is being assembled, A was 25. When you write move CL, A, assembler cannot substitute 25 because right now it's 25, but on execution A could have any value. I hope you understood my point. So, instead of substituting its value, assembler will substitute its address. Tell me, is this clear? Remember this in every language. That's why your teacher would have told you, whenever something is not going to change in a program, don't make it a variable, make it a constant. Something like pi in C programming, 3.14, whatever. If you ask your teacher, he or she would have told you, what's the advantage of making a constant? If you make a constant, you're taking a promise that this is not going to change. So the assembler can always substitute its value. So it executes fast because the value is there in the instruction. It is immediate addressing them. I hope you remember addressing modes. But here, if it's a variable, assembler cannot substitute the value. Assembler will substitute the address. Processor will go to that address. From there, it will pick up the data. So it will take a little longer, but it will give you any value that would be there of the variable at that given point of time. So moral of the story is, if something is never going to change, don't be a fool and make it a variable. Make it a constant. Your programs will work faster. If something is going to change, then you make it a variable. That's why you call it variable. Okay, I hope you understood this. This is forever. Now you understood this. In any program after this, I'm not going to teach you variables. Now you understood what is a variable. You're going to just be randomly using them everywhere because you need variables in every program. Now look here. So when you write move CL, A, assembler will not substitute the value. Assembler will substitute the address. Which address? The offset address. Say it again. Which address? Offset address. Offset address of A. So suppose the offset address of A was 2000. This instruction will not be move CL, 25. This instruction will become move CL, square bracket 2000 when it goes to the processor. Tell me, did you understand this? So moral of the story, whenever we write a variable, assembler substitutes its offset address. Offset address. Are we clear? Now that you understood how a variable works, we focus on our program. Don't forget, our program was not to add 8-bit numbers. Our program was to add 16-bit numbers. So that's what we want to do. Now we want to add 16-bit numbers. 𝐴𝑑w9384. I've created a variable by the name A, defined as a word with the value 9384. Why did I write DW? Because I want a 16-bit variable. Now, space will be reserved in the memory. Since it is 16 bits, 16 bits will require two locations. It will be called A, and it will have the value 9384, that is 84 and 93, by the principle lower byte lower address, higher byte higher address. All these basics have been covered in much earlier lectures. Please go through them. Okay. Otherwise, I just told you right now in case you're not. Lower byte is always stored at the lower address, higher byte is stored at the higher address. Now, look. So that was A. Just a small test of yours. Come on, just a small test. If I write move CX, A, who is getting what? CX is getting the value of A. What is the value of A? 9384. CX will get 9384, no doubt. But will the assembler substitute 9384? No. Assembler will substitute its, yes. Which address? Offset address. Say it again. Which address? Offset address. Now think about it. A has two offset addresses because it's a 16-bit variable. So suppose these addresses are 2000 and 2001. Which one will the assembler substitute? The first one, that is 2000. So this instruction finally will become move CX, square bracket 2000. The moment processor sees that it is CX, it understands CX is a 16-bit register. Since it's a 16-bit register, you will get data from two locations. So it will pick up data from 2000 and 2001. Did you understand this? So, similarly, let's create more variables. I need to add two numbers. So second variable will be DW1845. A third variable to hold the result, that is sum DW. Whatever value, whatever values you've given will be added. So we will give it as a question mark. We are not going to add them and write, obviously, that our program is going to do. We're going to keep it as a question mark. So what have we done? We have made a variable, but we have not initialized it. It's like writing int, okay? Yeah, it's like writing int a in a C program. You have created a variable, but you have not initialized it. The variable still works. Is actually it will right now contain garbage value. So same thing. When you write some PW and a question mark, first of all, this is your B, that is 1845. Now, this is your sum, which will contain garbage value, some garbage value, which our program will fill over here as a result. And you need a carry. Remember, when you write a program to add two numbers, there will be a sum, there will also be a carry. Okay? So you need a carry variable. Also, carry can only be 0 or 1. Add the two biggest numbers, you'll come to know. Say for example, 9 plus 9 can never be 20. 99 plus 99 can never be 200. If there is a carry, it will be 1. If there is no carry, it will be 0. So since carry can only be a 0 or a 1, I don't need to waste 16 bits on it. An 8-bit variable is also good enough. I would rather actually prefer it to be a 1-bit variable, a bit variable. Now that is not allowed in 8086 language. It's allowed in other processors, higher processors, but it's not allowed ironically in 8086. So in 8086, the smallest thing you can declare is a byte. So I'm declaring as a byte, db, again with the value question mark. So one location will be reserved and it will be called carry and will contain garbage. Please tell me, did you understand this? Henceforth, in many other programs that we're going to do, I'm not going to teach you all this. If I ever need you to make me variables, will you be able to create variables? Will you be able to start an assembly program? Will you be able to do this much? Because this is required in every program. Now look here, I'm going to ask you a tough question. Go look here. Out of all of these, how many are instructions? You're right, none. None of them are instructions. So if they are not instructions, then what are they? They are called assembler directives. Say again, what? Assembler directives. Why such a name? Because all this information is only for the assembler. Processor has nothing to do with it. You tell me, anywhere if I write A, what is the assembler going to substitute? Yeah, the address. Which address? Offset address. So when it goes to the processor, what goes is not A, what goes is the offset address. Processor will never know its life whether I've called it A or B or C or D or anything. This information is only for the assembler. So all this is called assembler directives. They are only for the assembler, they are not for the processor. Did you understand that? Now look here. There is a very important assembler directive that has to be written over here called assume. Assume 𝐶S::code, ds::data. Read it out. Assume 𝐶S::code, ds::data. What are we doing? We are telling the assembler, yes, it's an assembler directive. We are telling the assembler, assume the segment whose name is code to be the actual code segment and the segment whose name is data to be the actual data segment. Listen, you will understand. My guarantee, 15 minutes from now, you'll know this program, you'll be able to teach it to others, okay? But you're going to give me a patient here for some time now. Come on, look here. Remember, right in the beginning of the video, I told you, data and code, what are they? They are just names. You could have called them X and Y, doesn't matter. Now, you are associating those names with the actual segments. You're telling the assembler to assume the segment whose name is code to be the actual code segment and the one whose name is data to be the actual data segment. Suppose I would have named the segments D and C. What would this statement be then? Assume 𝐶S::C, ds::D. It would still be a valid instruction or valid statement. Tell me, did you understand this? Now, also, did you pay attention? I said, is this an instruction or an assembler directive? Exactly, it's an assembler directive. That means you have given this information to whom? To the assembler, not to the processor. You only told this to the assembler. But for a program to work, this information also has to be passed to the processor. I am the processor, this is the memory. For me, any area in the memory can be the code segment if CS register gives its base address. Similarly, any area of the memory can be the data segment if DS register gives its base address, that is the segment address. So, if you want this program to work, you have to put the address of data and code into CS and DS. You need to initialize CS and DS. Tell me, did you understand this much? Okay, you need to initialize CS and DS. Now, look here. So, we need to initialize CS with the segment address of code and DS with the segment address of data. Only when these addresses are put into these registers of the processor, only then the processor will treat them as the actual code segment and the actual data segment. You would ask then, what is this statement for? Remember what I said, this is for the assembler. Now the assembler has understood who is what. Now you have to pass this information to the processor. Who is the actual segment, who is the code segment and who is the data segment. Now listen. In our program, we need only code and data. We don't need stack and extra segment in this program, so we're not initializing them. When you require, you'll be initializing those also. Now here we need to initialize DS and CS registers. DS and CS are registers, okay? I'm sure you know segmentation, okay? Otherwise also just keep listening, you'll get it. Never make an attempt to initialize the code segment. Listen very carefully. This is the last of the formalities and then you're done. Never make an attempt to initialize the code segment. It is humanly impossible. You, me, your college principal, my college principal, whoever in the world, a human being cannot initialize the code segment. It has to be auto-initialized by the assembler. Why? You'll know very soon. 2 minutes and you'll know it. Right now just hear what it is, you'll understand why it is very soon. So we never initialize the code segment. Code segment is auto-initialized by the assembler. That's it. So we have to only initialize the data segment. Now, to initialize the data segment, I need to put the segment address of data into DS. For that, we need to write an instruction. The first instruction of the program is coming up. Remember, none of these are instructions, they are assembler directives. Your first instruction begins now. Wherever you write your first instruction, you write the word start. Yeah, the same start. Okay, there is deep meaning to it. You're just on the verge of learning it. Okay, pay attention. You can't write starts. You can't write I am going to start or starting or begin or whatever. The only thing you can write is start, and there is a reason behind it. Look here. When you write start is a label. Wherever you written start, your program will begin execution from there. Now, when you write move ds, data. This is an instruction. Assembler will convert this into machine language. Who will convert? Assembler. We write, assembler converts, 𝗵𝑝 executes. Remember? So when the assembler converts this into machine language, for move ds, assembler will substitute its opcode. For data, you answer, please answer. What will the assembler substitute? For data, what will the assembler substitute? The address, you write. Which address? Yes, say it aloud, let people around you hear, who cares? Which address? Segment address. Say again, which address? Segment address, not offset address. You will say, sir, you're contradicting your own self. Some time back I told you, whenever we write the name of a variable, the assembler substitutes the offset address. I still say the same thing. Pay attention to the words I'm talking. Whenever you write the name of a variable, the assembler will substitute the offset address. Data is not the name of a variable. Data is the name of a segment. A, B, sum, carry are variables. Data and code are segments. Did you understand what I said? 1 minute, only 1 minute. I'm taking about this. I'm taking you to compiler construction because I know it. So I'm just sharing it with you. It's knowledge. It won't go waste. It will make you understand things better. Just one. It won't take more than a minute. When the assembler does this conversion, assembler makes a table called as symbol table. In that, it keeps a track of every symbol and its information. The information is very big. I'm not getting into all of it. I'm just giving you the idea. What is a symbol? A symbol is any user given name. I say again, it is any user given name. Okay, any name given by us in a program is called a symbol. Now, start scanning. Think you are the assembler. In this line, is there a user given name? Yes. Which one? Data. what have I written next to data? Have I written dB, dW? If I would have written dB, dW or something, that means it's a variable. I have written segment. That means assembler understands. There is somebody by the name data, it is a segment. Assembler will store that information in this table. Data is a segment. Now, come back. A. What is written next to A? dW. That means it's not a segment, it's a variable. So assembler will store A is a variable. Go on. D is a variable. Sum is a variable. Cal is a variable. Again, data already recorded. Next, code. Code is also a user given name. That means it's a symbol. Code is a segment. And so on and so forth. This table is called symbol table. Now, whenever assembler encounters any symbol in a program, it will look at the symbol table to know what it is and what to substitute. So, if assembler sees move 𝐶𝐿, who gets what? CL gets the value of BL. There is no symbol over here. So assembler will not even go to the symbol table. Will directly substitute the opcode because there is an opcode for this instruction. Please tell me, did you understand this? Instead, if you've written move CX, A, assembler will see there is a symbol over here. Who is the symbol? A. Assembler will go to the symbol table. In the symbol table, come on. In the symbol table, do you see A? Yes. What is it? A variable. That means you are trying to use a variable which you have. That means you are trying to use a variable which you have defined. So it's all valid, legal. Assembler, since it's a variable, assembler will substitute the offset address. Instead of that, if I have written B is again a variable, assembler will substitute the offset address. Because I have written data is a symbol, it's a user given name. Assembler will go to this table. Data is not a variable, data is a segment. That is why assembler will substitute the segment address. Please tell me, did you understand this? Now look here. Suppose I have written move CX, total. Assembler sees there is something brand new over here. It's a user given name, total. Assembler will go to the symbol table. Do you see anybody by the name total over here? No. Sad. What does that mean? What does that mean? Put it in context. Comprehend this. What does it mean? It means you are trying to use a variable which you have not defined. Rookie mistake. So many people in their first few programs do it. I'm sure you also sometime in your life in C program you would have done it. Try to remember, when this happens, if you try to use a variable that you have not defined, you get an error message on the screen. Am I right or no? What does the message say? Undefined variable. No. Try to remember more. It says undefined symbol. Yeah. Why undefined symbol? How can it say undefined variable? If it knew it was a variable, then how is it undefined? It could have been a variable, it could have been an array, it could have been a character, it could have been so many things. It doesn't know what it is. So it can't say undefined variable. But it knows it's a symbol, and the symbol has not been defined because it's not there in the symbol table. So that symbol table gives you the message. Now coming back. So I'm sure I've made my point clear. Because we have written data since it's a segment, assembler will substitute the segment address. Tell me, did you understand this? By doing this, you have got DS register to this place. Now this has actually become the data segment. Tell me, did you understand? Now listen. This is what we want to do. But there is a small syntax issue, very small. You can't write move DS, data. DS is a segment register. You know the architecture. Please tell me you know the architecture of 8086. DS, SS, CS, ES are segment registers. Segment registers cannot be initialized directly. The only thing that can put a value inside a segment register is a general purpose register. There are 4 general purpose registers: AX, BX, CX, DX. So I cannot write data over here. I can write AX, BX, CX or DX. So what do? I can write move DS, AX and move AX, data. Tell me, did you understand this? First line, come on, together. When we write move AX, data, we are getting the segment address of, say it, I wish I could hear you. We are getting the segment address of data into AX, and then from AX we are passing on into DS because you will not initialize DS directly. Suppose somebody in VIVA, that is oral exams, in India we call it VIVA, wherever you are. In an oral exam, in an interview kind of a thing, 1-to-1, somebody tells you, put 2000 in DS register. Don't write DS, move DS, 2000. This instruction will never execute. If you want to put 2000 in DS, you first write move AX, 2000 and then move DS, AX. any segment register can only get a value from a general purpose register. Please tell me, did you understand? The reason for this is in the architecture. Segment registers are present in the VIU, general purpose registers are present in the EU, only EU does execution, etc. I'm not getting into that, I'm not teaching the whole architecture right now. But the point is, if you want to put anything in a segment register, it has to be done by a general purpose register. Please tell me, did you understand the statement? Now, with this, we have initialized the data segment. If in our program, there was also an extra segment. Now I want inputs from you, my job is almost done now. If there was also an extra segment, what are the additional things that would happen? Tell me right from the beginning, okay, come on. Say it aloud. There would be extra segment, blah, blah, blah. Extra ends, data segment, blah, blah, blah. Data ends, code segment, come on. Assume, yes, CS:code, comma, DS:data, comma, ES:extra. Okay, then start. Move AX, data. Move DS, AX. Move AX, extra. Move ES, AX. Tell me, did you understand what I just said? Okay, so this is how we would also initialize the extra segment. Similarly, if there was a stack segment, we would also initialize the stack segment like this. But we can never initialize the code segment. Now is the time. You are going to answer. I am not going to answer. You are going to answer. Why can we not initialize the code segment? What's the problem? Look here. If I had to initialize the code segment, what would I write? Move AX, code. Move CS, AX. Correct or not? Like how we do it for every other segment, we would have done this for code segment. Then what's the problem? Hear me. I'm sure by now some of you all would have already realized what the problem is. Come on, it's very obvious. It's right in your face. When we are writing these two instructions, we are telling them UP. When these two instructions are executed, this becomes the data segment. You're right, fine. When these two instructions are executed, then this becomes the code segment. How stupid. Come on, think about it. If this is not already present in the code segment, how would these two instructions get executed in the very first place? How can you declare a code segment by writing instructions? Instructions have to be present in the code segment in the very first place to be executed. Tell me, did you understand what I said? You as a human being cannot create a code segment. Is my point clear? To create anything you need instructions. Code segment cannot be created by instructions, because if those instructions are not in the code segment, how will they get executed at all? So the assembler has to create the code segment and hand it over to you. How does the assembler do it? Wherever you write the word start, that's the meaning of that start, which cannot change. That word cannot change. Case is not a problem. Assembly language, 8086 assembly language is not case sensitive. So you can write in uppercase, lowercase, that is not a problem. But the moment you write this label start, whatever assembler was doing will take a jump and come over here. It's called an inter-segment jump, so it will deactivate the old code segment and automatically establish this as the current code segment. Once it comes here, it gives you the control to do what you want. But somebody has to make the code segment for you to start writing instructions. Tell me, did you understand this? Now I'm going to take you back all the way to C programming, and this will make you understand C programming better. Answer two of my questions. Where does the C program start execution from? Don't tell me hash includes and all. Those are just the initial part that we write, including other files. Where does the first execution happens from? Where is the first executable line? The first executable line is inside main. After you write main, the curly bracket, the opening curly bracket, below that, whatever you write is your first executable line. Tell me, did you understand this? Now, I'm sure you've written lots of programs. I hope so, at least some. Inside main, you type instructions, blah, 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 and they execute, of course. You can also make functions. I'm sure you know that you made functions. You make functions outside main. Now when you make functions, you give them a name. You can give them any name. I'm sure you've used functions. Whatever code you've written inside a function, maybe the best code of your life, unless you call a function, the function will not be executed. I'm sure you know that. You may write the best code, but if you forget to call it, it will not be executed. So what are the two things you have confirmed with me right now? First, you can name a function anything. Second, you have to call a function. Only then it will be executed. Now, main is a function. In C programming, main is a function. Your first line, you said A function can be called anything. Can you change the name of main? No. Second line, you said a function has to be called to be executed. You have to call the function. Yes. Do you call main? Have you ever thought of it? How is this so much contradiction in what everyone is saying and what's happening? We always say a function has to be called. Main is a function. Main executes, but we don't call main. Why we don't call main? Because where will you call main from? You get control inside main, which means somebody has to call main and give you the control. Only then you can execute the program. Who does that? The compiler. Over there, the compiler calls main and hands over the control to you. Similarly, over here, the assembler initializes this as the code segment. The difference is, over there, you have to make a function by the name main. Here, you put a label by the name start. You cannot call that main mains or mainly or my main or whatever. Similarly, you cannot change the name of the start. Tell me, did you understand? This is the whole concept of 8086 program, how it executes. This is clear? So, this start has to be compulsory, and that's what is this end start. End start means end this program that started with the word start. That's obvious. One last formality that is needed is, this is just a formality, whether you write it or not makes no difference. int03h. int means interrupt, 03 is a number. I'm going to be covering a lecture on interrupts of 8086. There are 256 interrupts, their numbers go from 0 to 255. Every interrupt has some role to play. int21, super important. If you have a practical exam, you have to know what is int21, otherwise you can't do anything. All user inputs, all user outputs are done by int21. I'll be covering an entirely different video only on that. Okay, anyways, coming back over here. Coming back. What int03 is very petty, it's a very simple thing. int03 is called breakpoint interrupt. What does it do? It creates a breakpoint. So it stops your screen. Wherever it was, it will just stop your screen. So you always write it at the end of the program. What's the advantage? Your program executes, the screen stops, so you can see your result. You press any key, you come out of it. Yes, you got it. It's exactly like getch. Getch, get character in a C program. Getch also just stops your screen, so does int03. Whether you write it or not doesn't make any difference to the logic of the program. Okay? Now all this was the formality required to execute any program. If you notice, till now we have not started adding the numbers at all. That's what we're going to do now. Okay? Fair enough. What did I tell you right in the beginning? Your program will be only this much. But to do the program, you need to do all of this. Only then that program will execute. Before I go there, just for my happiness, for my satisfaction, 1 minute recap. You made a segment by the name data. You made variables by the name A, B, sum and carry. You ended your data segment, started your code segment, told the assembler, this is the data segment and this is the code segment. The moment you write start, assembler initializes this as the code segment. Now, you have to still initialize your data segment. You take the segment address of data into AX, from AX you pass it on into DS. You write int03 at the end of the program to create a breakpoint so that you can see your result. To pause the screen simply. You end your code segment and then you finally end the program that started with start. Okay, now let's write a program. A program is very simple. A program is to add two numbers. Our program, our question, add two 16-bit numbers. We have created variables A and B. We just have to add them. So students say, what's the big deal? Add A comma B. No, again, a rookie mistake. So many people make this. Remember these words. You can operate on register, 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 memory, memory, register, but not memory and memory. Did you understand? In one instruction, there cannot be two memory operands. Any 808, any Intel processor, not microcontrollers, processors. Any Intel processor has this rule. In one instruction, there cannot be two memory operands. You want me to write add A comma B. What are A and B? They are memory operands, they are variables. For both of them, assembler will substitute their address. You cannot have such an instruction. So what do you need to do? Take one of the values into some register. Take any value. You can take A or B, choose one. Let's say A. You're going to take it inside some register, choose a register. Let's say AX. So what are you going to do? Move AX comma A. You got your first number in AX. Now, second number B, you want to add. It's your choice. You can take B also in BX and then add AX and BX, or you can simply add them. I'll simply add them. I don't like to stretch programs for no reason. Some people have that habit. So, to each one his own. It's your skill, how you want to make it. I just don't like to write unnecessary instructions. So, simply add AX comma B. We took the first number in AX, we added the second number to AX. Now, what does AX have? The sum. The sum right now is in AX. We have to store it in sum. AX is 𝗵𝑝's register. Sum is our variable. So we have to transfer it from AX to sum. How do you do it? Move sum, comma x. So there goes your total inside sum. Did you understand it? 90% of the program is over. It's almost done. What is the last part? Carry. AX had the sum. We put it in sum. Who has the carry? The carry flag. So we have to check the carry flag, and based on that, put the carry inside a variable called as carry. Please do not get confused. You understood all this big thing. Don't get confused with this silly thing. Carry flag is the flag who holds the carry. We have to get it into a carry variable. Looking at the carry flag, we have to decide the value of carry variable. If carry flag is 1, we will make carry variable 1. If carry flag is 0, we will make carry 0. Did you understand? I'll say it again. If carry flag is 1, make carry 1. If carry flag is 0, make carry 0. Did you understand? Now, a friendly advice. Put it right into your head and remember it throughout your engineering career, not only for the current exam. Always. As long as you're doing programming. See, I always say, if you're my student in my class, you know, these are words I keep saying all the time. You don't learn programs, you learn the skill of programming. I'm teaching you a skill right now, this right very moment. I'm teaching you something very important, which will be useful in every language. Okay? Whenever you write a program where something can have only 2 values, like over here carry. Carry can only be 0 or 1. Don't be a fool who keeps it blank. People do this. They keep it blank and then figure out both values. Why are you doing that? You know carry can be only 0 or 1. Be a smart person and initialize it with one of the 2 possible values. I had to keep carry something instead of keeping it garbage and then figuring out both values. It's like you checking a coin. A coin can only be heads or tails. You checked out. Is it heads? No. Now is it tails? Fool. If it's not heads, it is tails. Assume one and just check for the other. By just putting 0, 0 over here, I've reduced my work by half. Now I don't have to take care of 2 conditions. I have to take care only of 1 condition. What have I assumed? There is no carry. So if there is no carry, after this addition, suppose there is no carry. My program is already working. Magic. I didn't have to take care of that no carry case. It is already working. I only have to take care of 1 case now. Which case? If there is a carry. Now if there is a carry, carry should become 1. How do you make carry 1? Increment carry. You can either write increment carry or you can write move carry variable comma 0 1h, whatever you prefer. Both of them are the same, however you want to write it. There are so many ways of writing instruction. So when I write increment carry, I am saying increment is variable by the name carry. Tell me, did you understand this? Now the question is, when increment means if carry was 0, so incrementing it would make it 1. I am sure you understand that. Now the question is, when do you do this? If there is a carry. So, last line, program is what? Just last line. We took the first number, we added the second number. I want to check if there is a carry. There are 2 options. If there is a carry, I will increment carry, that is make it 1, store the sum and end the program. If there is no carry, I should not do this. I should not touch carry, but I still have to store the sum. So, if there is no carry, I will jump to a label called as skip. That's it. Program is over. If there is see, this is the first time you're using an if in a C program. If this was C program, you would have written if. Instead of the assembly program, so this is how you do it. Okay, learn how this is done. There are 2 possibilities. There could be a carry or there could be no carry. If there is no carry, I will jump and directly store the sum and end the program. If there was a carry after this addition, suppose the numbers were such that it produces a carry, I will then jump if no carry. But there was a carry. That means it won't jump because the condition is not satisfied. So if it will not jump, where will it go? By default, program always goes sequential. So if it doesn't jump, it comes here. So I'll say it for the last time. You added your 2 numbers. If there was a carry, it will not jump. That means it will increment carry and then store the sum and end the program. That is if there was a carry. If there was no carry, it will directly take a jump and just store the sum, will not increment the carry. Tell me, did you understand this? Carry is something that happens in so many situations, not only in this program. So after this, in any program, if you have this situation of a carry, there is a simple way to handle it. Assume there is no carry. Make a variable carry, always assume it to be 0. Whenever you've done your operation after which you have to check for carry, if there is a carry, increment carry. If there is no carry, jump. Jump not over the whole program. Jump over the line where you're incrementing carry. That's it. This is how you handle carry in every program. What is skip? Skip is a label. Just like start is a label, skip is a label. Start can only be called start. Skip can be called whatever you want. Skip means we are jumping to skip. So if I would have, instead of skip, if I would have called it down, I would have written J and C down. I would have called it next, then I would have written J and C next. But here we are not jumping in coming. The assembler is pre-programmed to jump and come to a label by the name start. If you have not written start, your program will not execute. Tell me, did you understand this? Is the whole program clear? Now I've tried my best to make you understand this language and this program. Now you tell me, this is a program to add 2 numbers, whether to subtract 2 numbers or multiply 2 numbers or divide 2 numbers or whatever. You understand most of the part will be the same. The way you make segments, the way you declare variables, the way you write, assume, the way you initialize your segment, the way you end your program will be the same. What will change is the core of the program. Okay? I hope this has given you, I've put in really my best right now. I hope you understood this. And after this you see more programs, all programs. About 15, 20, 25 programs are there in my own book. Plus you can get programs on the internet. Not just programs, the whole instruction set assembly language, the whole interfacing, the crazy interfacing of 8086, minimum mode, max mode, etc. And introduction to 386, 486 and Pentium. It's all there in my book. My book is available on Amazon. You can check it out. You can get a hard copy. It gets delivered generally in 2 days. You can get a soft copy. It will be delivered instantly on your phone. I would want to do a video on all programs, a video each on every program. They will not be long. This is the first program where I'm teaching you programming, so this was such a long video. They will be very short, 5-10 minutes max. As and when I get the time, I will upload them. And yeah, one last thing. Listen, one last thing. As I said, there are several assemblers. So some assemblers have a slight tweak in the syntax. Okay, slight tweak. Don't worry, nothing to it. You may not have data segment, you may have @data. Dot data, I'm sorry. You may not have data segment, you may have dot data. Okay, so there are some assemblers which have this rule. Some assemblers instead of using data segment, they use dot data. Okay, that is fine. That is fine. That's a different syntax. Like you know how in C you can write C out also, and you can write printf also. Both work. It's just different compilers use different syntax. So similarly, instead of data segment, they use dot data. Now, if your college is using that assembler, I'll tell you the changes. I'll just go through. There is 3 changes. Instead of data segment, it will be dot data. There won't be segment. There will be no ends. Similarly, there will be dot code. No code ends. Your main end will be there, of course. Start will be there. The assume statement will not be there. And will be move AX, @data. Does exactly everything that I told you, just the syntax is different. So I'll tell you the changes. It will be dot data, dot code, move AX, @data, telling the assembler that you made a segment by the name data. Because we earlier had data segment, now that is not there. So that @tells the assembler to substitute the segment address. And since you have not written code segment, since you have not written that word segment, there is no question of the word ends. So when the assembler changes, these minor tweaks happen. In case you still have a doubt about how your college practicals programs work, anything here and there, feel free to call me. My number is there on the description section, is there in the about section of, you know how it is, right? It's not that difficult to get a number of any person. So just feel free to call me or text me, WhatsApp me, whatever you want to. And there's massive request from 𝗵𝗏 students to make a video only covering bypass, or the oral questions, because the exams are right just around the corner. If I get the time, me and my staff who's doing the camera work, Ajit, we both have been up day and night making these videos. It's not that easy, but as soon as I get the time, I'll make it. Enjoy yourself. Have a good time.